Hello, everyone. Welcome back to the 12th episode of the Day Zero podcast. It's been a while. I'm Spectre. With me is Z and Anti. If you're watching the VOD or the stream, you'll notice we have some different icons, except for Z. He doesn't like change. Um, but yeah, so it's been a little while, but we're back now. And yeah, so I figured we'd start off the show talking a little bit about what we did over the summer, which for me was DEF CON 27. So yeah, so how have you guys been doing?
You know, kind of the usual here, keeping busy. I didn't make it out to DEF CON. I considered it, but didn't happen. But I think as
Just
usual,
wanted to
just kind
avoid
of
me.
pretty much as usual though. I think DEF CON's kind of been growing every year. I think do you know what the attendance was this year? I think it was something like 30,000 or something.
I want to say it was around 30,000. I know last year's was 26. Um yeah, so I'll talk a little bit about that. So this was my second year going because last year was my first. So this year was actually a little bit different though. So there was more people, right? There was 30,000 instead of 26. But they had a different layout, right? So last year, and I think most of the years before, it was in two casinos. It was in Flamingos and Caesar's Palace. This year it was in Paris, Bally's, Planet Hollywood, and Flamingo, I think. So it's still Caesar's properties, but it was spread out over more casinos.
Yeah,
And
it did run in just one hotel for most of the years, actually, up until I don't remember what year. I think Rio was the last time that it ran in a single hotel.
oh,
Um,
okay.
and then it moved to Paris and Bally's, which it was for a couple years. And then, yeah, as we're kind of getting now with many more hotels.
Yeah. So I mean, it was kind of a trade off. There were some people that were complaining about having to walk more and stuff like that. But the upshot was villages and stuff like that had way more room. So one example was like the hardware village. The hardware village this year was like it was huge. There was like probably 10 times more seats than there was people there. Whereas last year it was basically a closet and there was like so many people in the room it probably violated the fire code last year. So there was a lot more room. So overall, I think I liked it the way they did DEF CON this year, like more spread out.
Yeah, I mean,
Yeah, there was more walking, but
I heard they moved the CTF also, so the main game was kind of out of the way. Couldn't really walk by or didn't really have as many distractions going on in there.
oh yeah, I completely forgot about that. That's a good point. Yeah, so they had the CTF at Planet Hollywood, I think. So most of the stuff was in Paris and Bally's, and then I think Flamingo had maybe a few villages. But yeah, I remember hearing about that because I heard CTF teams from like the last couple years. They were saying like it was kind of hell to do it because it was so loud. There was so much noise going on. But yeah, this year I actually stopped by the CTF because I had a friend that was actually doing the CTF, and yeah, it was dead quiet. It was really nice to go in there, and we were talking low and stuff like that, and it was just yeah, it was really quiet until like 8 o'clock came around and Hacker Jeopardy started up. Then it wasn't so quiet. But by then, I think 8 p.m. was the cutoff time for the CTF anyway. So
Well, cut off, who keeps working through the night though. That's
oh
it. I
yeah,
heard
cutoff for
about.
like that main area. Yeah.
Yeah, yeah, no, I know what you mean. Um, I heard there was, or actually, I'll say this: the transparency report for DEF CON, what was it, 27 this year?
Yeah.
They make mention of a. So, I don't know if you're familiar with the transparency list, but
I
trying.
think I've seen it before, but I don't really pay too much attention to it.
Yeah, I'll
That makes
open it
sense.
here.
Okay. That talks about like incidents,
Essentially,
right?
yeah, it talks about incidents, but one of the incidents is one biblical grasshopper plague. So, how were the grasshoppers?
They actually weren't as bad as I thought they'd be because I saw that video posted on Twitter in like July or whatever it was, and they were like everywhere. When I got there weren't actually that many out. You could hear them, but I didn't see too many of them. So
Yeah, okay. I said I missed this year, so I definitely. Oh no, it looks like they confirmed here that was 30,000 attending.
oh yeah, okay. Um,
What were the past years? 28,000 last year.
Oh,
25.
okay, that's more than I thought it was. So it went from 25 to 28 to 30.
That's what it
Interesting.
looks like, yeah.
There was a bit less people that, or like new people that went this year.
Yeah, I
Um,
don't know. It's still growing like crazy.
oh
I
yeah, for sure.
mean, I don't think it was even 10,000 for Defcon 21.
Yeah,
They don't. This page just goes to 25, so I'm not sure, but I'm
yeah,
pretty sure it's at least like doubled in those few years.
yeah. One thing I did want to say is there were some few cool things that happened this year. One thing was Hacker Jeopardy, which I love, was actually made a black badge event this year. I don't remember if I told you that or not,
Yeah, I
but
don't recall.
yeah, they made that a black badge. But yeah, no, DEF CON was pretty good. The weather was nice while we were there too. It wasn't blistering hot. It was only like 100 degrees instead of like 105. So you could walk outside for a little bit and for like 10 or 15 minutes and not get toasted, which was not the case last year. Last year was super hot when I was there.
So,
Um,
I guess if we're talking about the conference, um, personally, like when I tend to go to conferences, I tend to trade more as a networking event. I don't care a ton about the talks unless it's a conference that isn't recorded, or they have unrecorded talks. Like DEF CON does have some of that. But did you go to any talks or any that you can recommend people try and find the VOD for?
so it's funny actually. Last year I went to quite a few talks, and this year I didn't go to any of them.
That really seems
Um,
to be the beginner mistake. The conferences, you go there thinking like, yes, I'm going to, and I did this my first time at DEF CON. It's like I'm going to attend like every talk. I'm going to live in those talks. Then you realize that there's so much more to do with these conferences, and the talks are going to be online.
yeah, yeah, I mostly checked out the villages and stuff like that. I went to the vendor area this year. They had a huge vendor area and a lot of really cool stuff out. So that was where I spent actually a lot of time, was checking out stuff there. There was a really cool debug badge, which you could play like Battleship with other people that I got there. Um, so yeah, I didn't really check out the talks. I mostly checked out the villages though. And I tried one of the CTFs. One thing though was the CTF area. It was really large, but there wasn't a lot of seats or tables. So like pretty much everybody was sitting on the floor, which I don't really like doing with
Yeah, I
like
mean
when I'm
that's
doing
definitely
stuff.
happened in past. Like you're talking about the open CTF.
Yeah, yeah, the open CTF. Yeah.
Yeah. So actually, on that topic, so you played some of it. What were your thoughts there? Because I know it's a new organizer this year. I think it was Neg9 doing it.
Uh, I I think I had some issues actually connecting to the challenge page. Because I guess there was a lot of people on it, and like trying to load the page, either it wouldn't load at all or it would take like 2 minutes to load. So I actually didn't get to check too much of it out. Like I didn't get to check much. Like I wanted to check more out than I got to.
Yeah.
And I
Okay.
did it on like kind of the last day. I can't remember too much about the challenges. There was some fun challenges.
I
Um,
think I remember you possibly complaining about one, but I just don't
yeah,
remember.
I remember that too. I just don't remember which one.
It's been a little while, where being the podcast is being a little bit late here, so it's been a while
Yeah,
since this happened.
yeah. The I think there was a cool report that I can't find at the moment, but I'll probably link it in the YouTube VOD. But there was a link to like write ups for the main CTF event. So there was one CTF that I thought was kind of cool. I don't know if you heard about it. I think it was called ROP ROP ship. I forget what it was.
Yes,
So
yeah, I did hear
yeah,
about it.
yeah. So you had to use return oriented programming to basically like use a spaceship to like take down other team spaceships, I think, or
Yeah,
something like
well,
that.
it was a
It's really
competitive
cool.
game that you need to use the ROP chains to kind of build your not AI, but build your control system. Yeah, it sounded really fun.
Yeah, so I heard that there were quite a few fun CTFs or like CTF challenges this year for the main CTF. Um, there was one or two though that a lot of teams didn't like. I'm trying to
I
think
heard
of.
about one getting patched in the middle of the game.
Yeah, so one, there was a few teams that abused an exploit that made it easier to solve than was intended, and then they patched it midway through, and that kind of ticked off some teams because that seemed kind of
Well, I think
unfair.
it closed like another approach that would have been okay if I recall correctly.
Yeah,
When they closed the abused bug. And I mean that honestly does seem pretty unfair to do in the middle of the game. Like I get wanting to deal with unintended solutions, but at the
yeah,
same time, middle of the game, I kind of feel like it's fair if it slipped through that long.
yeah. And I think there was another challenge that like no team solved. I think it was like no team could find the correct solution. So
Yeah, well, I mean that's
yeah,
fair
they had a few.
compared to having every challenge solved really quickly. Having some
Yeah,
there that no one solves, I'm okay with that.
yeah, that's fair. But overall, I think it went better than last year, which makes sense. I think last year was the first year that Order of the Overflow was doing it, right? I think,
Yeah, that was the first year they were organizers. Legit, yes, before them.
yeah. So I think they had
Learning
a
from
better
some
go
of
around this
it.
year.
Yeah,
Yeah,
I don't recall seeing as many complaints this year, so we'll take that as a good sign.
yeah. But that's pretty much everything about DEF CON. But I did want to ask, Auntie, you went to a conference in Vegas too, didn't you? I think it was before DEF CON, wasn't it?
Yeah, I think he went to Black Hat.
Yeah,
Was it
well,
Black Hat?
as per usual, I'm the company man, so I found myself going to Black Hat this year. Yeah, I mean, I would say, it was interesting. I think the biggest fascination really that came out of it was the company that talked about quantum encryption and so forth, Crown Sterling.
Encrypting in 11 dimensions.
Yeah, they were playing some real 4D chess at that conference. So,
Well, just recently, even they did another thing, demonstrating their crypto breaking by breaking a 256-bit RSA key in like 50 seconds. Something my laptop can do.
I mean, they made it out to be like it was. They kept throwing the words in like quantum. We're using quantum, and we're using multiple dimensions to. It's just like And the funny part is when I first saw their booth, right? I thought it was like a liquor company, so I was really confused. Like I didn't understand what was going on here because their logo even looks like something that is either a pack of cigars or like would be a bottle of liquor. So I was very thrown off, and I actually stopped by their booth, and it was very confusing. I thought I just didn't know enough like crypto stuff, so I was like, maybe I'm the stupid one here. But they really each person had kind of the same shtick. They talked about it, you watched the video, and so on. So it was a great time. I hope anyone else that went to Black Hat got a chance to see their booth because it was definitely a nice refresher in the middle of the day of sales pitches right at you.
Well, I mean, it was another sales pitch.
Oh yeah, no, but it was one that was actually pretty funny.
Yeah, they definitely had a lot of backlash over that.
They're still getting a lot of backlash. Surprisingly, they are very adamant that it all works, though. So more power to them. They obviously had enough clients, I assume, to afford to go to Black Hat, or enough investment. So yeah. Outside of that, though, I mean, Black Hat, it's the normal. I would recommend DEF CON for most people. Black Hat was cool though. There were a few little things here or there, but I didn't go to the CTFs. I don't even know if they were hosting one this year.
Yeah, does Black Hat usually do any sort of CTF?
Sometimes they have like one or two they'll throw up for people.
Okay, because yeah, Black Hat's just kind of out of my price range for the most part, so I've never really bothered looking.
It's unless you're like for the most part your company's sponsoring it, or you're presenting there, or you're going to watch someone that's a friend who's presenting there, or something like that. Normally I wouldn't suggest to go again. DEF CON, you're going to find a lot more CTFs and stuff like that. Most of what you're going to do when you go to the little floor of where everybody's at, it's just people telling you about their business and trying to get you to give them your email and shit like that. So not a recommended thing. The talks even themselves are kind of, here's our product and here's how we used it to stop people on this skinny farm.
They've definitely had some good talks though, because there are usually at least a number of them that kind of get double presented, Defcon and Black Hat, which do get technical. But yeah, I mean, obviously Black Hat definitely has that more corporate feel.
Yeah, I think it's more of like sensibilities, not wanting to scare people. Defcon for some reason gets a rep of like, I mean, when I went there the first time, I think I was something 19 or 21. I can't remember, it's so far back. But when I first went there, I mean, we got in an elevator and like someone asked us like, "What's going on here? What's this conference?" We're like, "Oh, it's a hacker conference. It's called Defcon, right?" And like, "Oh no, our credit card's gonna be hacked and this and that." And I was like, "I don't think that's really how this works. They're not just gonna pull it out of thin air for the most part. Nowadays, maybe, but so there's like this weird like people are genuinely creeped out a little bit by the whole thing." But I think for the most part, I've never been spooked by going to DEF CON. I've never been as paranoid as everybody else for the most part, you know? Just don't plug into random outlets and whatnot, and you're usually okay.
And check for skimmers.
Yeah, I mean, but
or use cash.
Most people use cash anyways because, you know, they're like, I don't want, you know, the government or something to track me going to DEF CON or whatever. So most of those things, you know, but it's really not that scary. No one's trying to constantly pickpocket you or some craziness. DEF CON is definitely where it's at. But in summary of Black Hat, I mean, it was all right. It was just, it's about exactly what you would expect from a corporate DEF CON.
Yeah, one thing I'll add on to that, you know, discussion of, you know, people being paranoid and stuff. I mean, keep your shit up to date before you go there, but like, nobody's gonna 0-day you at a conference. They're not gonna risk burning a 0-day to pwn some random people going to DEF CON, because most people going to DEF CON don't have anything of value anyway to pwn. You know what I mean? Like, they're not gonna, like, most people don't go to DEF CON with their phones with 0 days on them or something that people want to steal. So, like, it's just not really worth it to do that kind of stuff.
I mean, it is kind of take the usual precautions, though. I mean, because it is a bunch of people that know what to do. So yeah, maybe people aren't going to be dropping 0 days to try and grab whatever, but you know, they're still going to be running the usual attacks against kind of the low-hanging fruit.
Yeah, exactly. That's what I mean. Like, keep your stuff up to date and stuff like that. But
I'd say the biggest things are don't connect to a Wi-Fi. That, you know, if you can, because obviously there's rogue APs. If you do connect stuff,
well, I mean, there's rogue cell towers too.
Well, that's what I was going to also say is update before you go. Don't update during, and then restart your phone when you get back. Because a lot of times, I have seen people who walk around with those big cell towers hanging out of their backpack. They're like mini cell towers, and they can push fake updates, right? So you should definitely not necessarily update while at DEF CON if you're bringing your regular phone or laptop and stuff. But these are all like common sense stuff you should know. You know, use a VPN if you're going to connect to something. Try not to connect to public Wi-Fi's.
Yeah, and area. I mean, it's DEF CON's passed already, so we don't need to give people their tips on that.
For next year.
Oh, we can talk about it next year, too.
This is good stuff in normal life, too, okay? You know, you could use this. You never know when you're going to get hit with some cell tower spoofing. You know?
Just me? I think it's a little less common around where I'm at, but...
I'll make it less. I'll make it more common. I'll make sure.
But talking about the 0 days, you know, we do have fairly recently the checkm8 exploit.
Yeah, before we do that though, I just wanted to add on to the end before we move on, just that Auntie, I don't know if you heard about this. I think C and I talked about it, but did you hear that Black Hat was actually getting sued by those guys for like defamation or something?
By Crown Sterling?
Yeah.
I'm scared to say their name now.
For that crypto, yeah, because they got booed while they were presenting, and they were like, "Oh yeah, that's defamation or something." They're trying to sue them.
Dude, there's you can find videos online of people recording it and calling them out, where they're like, "What are you talking about? That none of that makes sense." So, yeah, I'm not surprised, but I'm surprised. I should say I'm surprised they're suing them. I'm a little skeptical of how that will play out because yeah, there was a lot of people, dude, a lot of videos that surfaced of their presentation, and it was pretty hilarious. So yeah, maybe we shouldn't say their name. We can edit it out.
So if I recall correctly, the case centered around Black Hat actually planting people to defame the talk, not just people booing, but that Black Hat.
Yeah, there was saying
that's if I recall correctly. Yeah. So that at least gives it a little bit more of a leg to stand on in terms of being an actual case. I mean, obviously, they shouldn't end up needing to pay out or anything. But with that in mind, like, I could see why the legal system will at least still take it.
I'm sure it'll happen and they'll actually win because no one knows what the hell. They'll be like, but see, our quantum was actually good, so that's why it shouldn't have happened. They're like, that sounds right, yeah. I don't know, I'm going to go back on Facebook. You know, like,
but it has to be about, you know, Black Hat actually paying people and doing that, but...
Why would they? Whatever. But it's like a paranoid schizophrenic. Well, that's good to know. I'll just stop saying their name from now on so I don't get sued.
The company that must not be named.
Exactly.
Harry Potter type shit. All right, so yeah, we'll move on to checkmate. So I think it's pretty much impossible if you're listening that you haven't heard about this, but we'll talk about it. We'll introduce it a little bit. So it was a bug in the secure bootROM of iPhones. It works from A5 to A11 chips. So it's basically the iPhone 4S to the iPhone X. The newest iPhones, which run on A12 chips, I think they are actually vulnerable to the main bug that's used in this, but a different exploit strategy is needed because I think it needs to leak something or something like that, and that vector doesn't work on A12 chips. So yeah, so I'm not entirely sure on that. It may work on A12 as well, but I don't know if like an exploit will get released for that or if it's possible to exploit on A12. But one thing I found cool about this bug is that it's USB only. You need physical access to the device, so it's nice for jailbreaking and for researchers who now they don't need to hoard a 0-day just to maintain access to do research on the iPhone. But it's not very valuable for like attackers to use, right?
Yeah, I
So
mean,
thought
well,
that
you
was
need the phys. It still can be, but not remote attackers.
yeah, not
You know, like
remotely,
you
I
attacking
should
your
say.
girlfriend or something. Sure. That said, this is also, if I recall, it's not a persistent exploit. You have to keep doing it. So this is tethered. Am I?
Yep, it is. Yeah.
Yeah. So that also limits its use case, even with physical access for somebody like again going after a girlfriend or something. Um, since it needs to be tethered, you're basically getting your one shot of access.
Yeah. So the bug that was actually used in this, funnily enough, was discovered by patch diffing. So I think the bug was actually discovered 2 years ago by Apple, and they patched it. And then Axiom was like going through the versions or whatever and was patch diffing and found it through that. So it's obviously it was patched 2 years ago. Um, but it still works for like a wide range of devices, and it's a hardware bug, so it's not like they can remotely hotfix it on those older
Yeah, well,
devices.
it reminds
So
me a bit like, and it's in the boot ROM, boot read
yeah,
only memory. So it's very early in there. So that's why this is something that can't really be patched is one read only memory, so they can't just change it. That's it. It does remind me of the Nintendo Switch one,
yep,
where
very
they had
similar.
another boot area issue, and Nintendo actually did make an attempt at patching
Yeah,
it with software by kind of carving out a secure boot area in the TSEC, the Tegra coprocessor, or the security coprocessor. Obviously, it didn't work. Like 3 days later, it was done. But I don't know. I wonder if iOS or Apple will make any attempt at patching it. In some sort of creative way is what I'm getting at. Obviously, it can't be patched, but I'm wondering if they might come up with something, or since it's not on the
like on
most
older
recent
devices.
phone. Yes, well, since it's not on the most recent phones, I mean, maybe
Yeah,
they're not going to do anything. I could completely understand them not doing much, especially because the remote attack surge just isn't there. But
yeah.
oh no, having seen Nintendo do it, I'm actually curious to see if Apple would, especially as this gets more popular.
Hmm. Yeah, so there's a bunch of people playing with this. One thing I did want to rant a little bit about, not for too long, but so there was a JTAG cable released for this, but the cable's $800. So that cable's used for like debugging over USB and stuff like that.
So
Um,
cheaper than attending Blackhat.
I mean, still cheaper than attending Blackhat, but like, dude, I hate like I don't understand it. It's like hardware gets away with so much with like price gouging people. Like, there's no way you could reasonably expect like people to pay like the amount of like the price for the parts to make that cable is less than a tenth of that. I can guarantee it. And they're
Sure,
marking it
but I
up
mean,
to
you're
eight hundred
not
dollars.
just paying for the price of the parts. And
No,
I do
that's
agree.
true.
A lot of the hardware stuff, especially around USB, is where I've seen it. Ends up some of it is pretty reasonable now, but it used to cost like, thousands of dollars, tens of thousands to start doing USB level stuff, like analysis at the USB packet level. And I mean, it's kind of the same thing. Like, yeah, okay, I understand where some of the costs coming from. Like the difficulty in doing the research and figuring it out to build that cable, to build that hardware. Like, there's room for the, as you say, price gouging in there, like for the high price, because there's also very few people who are going to be paying for it. So, if you spend 800 hours on it, you want to make back 800 hours worth of your time in the profits.
It's the old prescription model. They got to charge you for how much the R&D costs, essentially. But that does create kind of an interesting question. Is there like a barrier to entry now because all this crap is so expensive, man? Like $800, who can throw that down? Most times especially if they're young.
Well, funnily enough, the cable actually did sell out for the 1 week, like the first week that they dropped. I think they do it like weekly cycles. They have a new batch, and it did actually sell out the first week. So it's probably all bought by the NSA anyway. But
I was about to say, exploit agency over there. Yeah, it's definitely bought by people.
Yeah, I mean, people do buy it, and you know what? I guess I'm kind of I understand free market. If people are willing to pay that, I guess then fine. It kind of drives me nuts that hardware is one area that like it's just gotten out of control with doing that kind of stuff. But yeah, I didn't want to rant for that for too long, but I did want to mention it. In closing, I did try to find out more about checkm8. Like I looked through some of the source. Man, it's not very easy to read through. There's a lot of constants and stuff being used that aren't labeled. Like these ones are labeled that you can see here, but a bit further down, like okay, I'll scroll back up because I guess it was a bit delayed. So these ones here on the USB T8015, like they have some constants for like the load address, exec magic, stuff like that. But near the bottom at device, where the device config array is, they have a lot of constants that they don't really label. So it's a bit tough to figure out what's going on here without any, I don't have any experience looking at Apple stuff or the bootROM or anything like that. But it could be an interesting exercise to try to, do like a write-up or something of how the bug works. As far as I know, I haven't really been able to find any public write-ups about exploit specifics or anything. Maybe that'll come out within the next week or two, and if it does, maybe we can bring it up again on the next podcast. But yeah.
Yeah, I haven't seen any myself, but I haven't really looked into it all that much.
Yeah. And one additional thing I'll mention before we move on is I don't think this by default works on Windows, because GeoHotz actually did a stream checking out checkm8, and I think he was trying to port it over to Windows. So yeah, I think you need a Mac to run this, or at least a Linux machine. But
okay.
Maybe somebody will change that. So, but I figured it was worth mentioning.
Yeah, it's definitely worth mentioning there, especially if somebody does want to go and try this.
Yeah. So we'll move on to another Apple thing. So there was another Project Zero report, which is titled "Debug Registers and Production A11 iPhones Allow Full-Featured Kernel Debugging." So what this essentially talks about is there's registers on the SoC that are used specifically for debugging, like using a core to debug another core. And for production devices, they usually try to remove these registers. I think they're called CTI registers.
Just disable them.
I think I don't know if they've. Let me see.
So I was trying to look into how it gets disabled.
It says directly that it's been removed. So, so they're called CTI, cross trigger interface registers. But there's an undocumented register called debug wrap, which re-enables access to some of the functionality provided by those registers. So you can do things like halt the CPU core in a debug state. You can force the CPU to never reset, or you can halt it in the next after the next reset. So one of the big things that this issue allows you to do is you can bypass the kernel text read-only region protection, which is basically hardware enforced kernel patch protection. So how you basically do that is you can just run a custom reset vector that just completely cuts out the KTRR initialization. So that's like the main use case that's pointed out for this. But you
So
do need
has somebody released like a public tool for that or anything? I noticed here that it was mentioned that he's been working on doing that bypass, but there's nothing further on it actually being done.
Yeah, I'm not sure. I haven't seen anything yet, but that maybe I just missed something that I didn't see. But
Fair enough. I mean, it's definitely
yeah,
something that's a possibility.
yeah. The only thing is, to even access this register, you need kernel read write. So it's not like you can do it from an uncompromised kernel. They even state directly in it that it's it might not explicitly be a security issue because you're basically what you're gaining access to is the ability to debug an already compromised kernel. But they still reported it because that ability to bypass stuff like kernel text read only region is of interest for post exploit stuff for like any malware that would want to do that or jailbreaks or stuff like that. So Apple had a few got hit with a few things this year because I think there was another thing they got hit with. I can't remember exactly what at the moment, but Apple's had a tough time of it this year.
Yeah, I mean, part of it's probably just more people paying attention.
Yeah, for sure.
But yeah, I mean, it's I could understand the people saying it's not a security issue. I believe that's mentioned in the report here. Yeah, I'm not confident that this is a security issue. That said, I'm reporting as low severity.
Yeah.
Over there, which is basically exactly what you had mentioned. Yeah, they're getting the ability to debug a kernel you've already compromised. I mean, it is a level of access that's useful.
Yeah, it's just post-exploit. So
yeah.
it's not, it can't get you a foothold. So, yeah, we just wanted to mention that in quick passing. There's not too much else to talk about on that.
Unlike that one, which, doesn't get you a foothold, the Android one we've got can be used for a foothold.
So I'll say I was amazed at how simple this bug seems to be. Like it seems like it's a fairly trivial exploit.
Well, the write-ups, or at least the description here, is done pretty well. Go ahead.
Yeah. So it's basically a classic UAF. It's not a race-induced UAF or UAF because of some weird circumstance. It's literally just they say when the epoll exits, the wait queue is freed, but it's not removed from the data structure, so it can be freed again. So it was a double free. I think this one was a double free, right?
Well, so it's a use after free, but it originates from a double free. So you get the double free, which then leads to the UAF. Because it still uses it, but then they... Alright, yeah, never free. No, it's not double free, it's just UAF. Sorry, I'm thinking of a later one.
Okay, I think I'm thinking of the exact... Yeah, I'm thinking of a later one too. Just ignore me.
Yeah, so this one's just use after free.
Yeah, so I thought it would be fun to have a bit of a discussion of like trying to figure out, how how exploitable this could be, but they actually directly mention at the bottom that we have evidence that this bug is being used in the wild. So I guess it's exploitable because they directly say that it's been exploited. So
yeah, that was kind of the most interesting thing to me, actually, was that it was actively being exploited. Second most interesting, though, is that this was patched in December 2017. It was upstreamed into Android February of 18. But yet the Pixel 2 and some other devices like the Samsung S7, 8, 9, it's still vulnerable in there, but this was patched in, like Linux kernel 4.14.
Yep. And I'll add something else interesting onto that. I think it was actually found by fuzzing. It was found by syscaller.
Oh, okay. I did know that.
Yeah. So syscaller found the issue in December 2017. I kind of want to see if I can bring up that report. I just got to look for the link real quick. It shouldn't take me too long. I bookmarked it because I want to talk about it.
So you're saying it was found like originally in the Linux kernel with syscaller. I was saying you were mentioning that was found kind of active in like Pixel 2 with that, but
oh yeah, no, it was found in Linux with syscaller.
Okay, cool.
I'm just bringing up the report here. So that's the syscaller report. Use after free unlock acquire. So yeah, Fuzzer's ahead of the game, but the vendors can't keep up. So yeah, don't.
I mean, fuzzing's definitely well, I don't know who would say fuzzing isn't useful, to be honest. I mean, fuzzing is. I mean, I understand wanting to do manual review, but fuzzing is absolutely effective.
Yeah, and I mean this issue is just highlights the issue with Android phones with how like split up like all these different vendors are running their own different versions that have different kernel upstream. Like, oh man,
well, I don't know. I mean, does Google though with their phones? Don't they run? Do they? I guess I haven't looked into this enough. Do they run their own Androids? I would have assumed that they were running more or less stock Android because I mean it's theirs. They can implement what they want.
Yeah, I don't know because it says that it was fixed in the Android 3.18 kernel. Or AOSP. I actually don't know what that stands for. I'm not an Android. Android open source project. Yeah. So I guess Pixel is running its own.
It's running its own, or it seems like the 8.x releases. It does mention other devices which appear to be vulnerable, referring to those. So I'm wondering if it got removed, like if the patch was removed at some point, and that's why some of them were still vulnerable, like those basically running the latest or that have updates to the latest.
Yeah, so for those of you who are just listening, I'll read off the list in case you're interested. So the list of the devices that are affected is the Pixel 2, the Huawei P20, the Xiaomi Redmi 5A, the Redmi Note 5. I don't even know how to say that phone name. Xiaomi? I'm just going to go with Xiaomi. A1, Oppo A3, Moto Z3, Oreo LG, and Samsung S7, S8, and S9. So, if you're running those phones, you know to update.
Yeah, I'm assuming an update's out for it.
Yeah.
I wouldn't be disclosing this otherwise.
Yeah. So I think I actually think I'm going to look into this bug a little bit more, see if I can exploit it. Maybe we'll do like a little video talking about it because I think that'd be really cool.
Yeah, I mean, it definitely, at least the description's really straightforward for this one. I mean, it's just the way Q gets freed if you exit using the binder thread exit constant, never removed from the epoll data structure. When the parent process to the epoll data structure exits, the cleanup tries to access the waitlist. We get the use after free. Like, really plain language there, really straightforward.
Yeah, so with that said, and I mean, if you're looking to get into kernel research, this is a perfect bug to break in with. Like, perfect. If you want to try to write an exploit, do this one.
Although, this is patched on the latest Linux, so you'll have to go back to the 4.14.
Yeah.
Or you do this on your phone. Or on a phone.
I'd recommend doing it on a desktop instead of a phone.
If you're learning, yeah.
It's easier, yeah. But maybe we'll do a video on that, because I think that'll be really cool. So moving on from that, we'll go to the PHP 7 disable functions bypass. So so from what I understand, I mean, I haven't really written PHP in a while, but from what I understand, disable functions is a setting in the INI file, right? To disable.
Yeah, I mean, you can call
functions.
There is a INI set, so you can set this from code. But yeah, essentially this would be using a shared host, the sandbox, to disable certain functions like shell execute and things of that nature, to disable users from actually using certain PHP functions.
Yeah. So unfortunately I don't understand too much about the PHP engine at the low level. And this does deal with the garbage collector, so it's it's pretty low level in the PHP engine. I initially thought when I was looking through it that it was a deserialization issue because you can see like unserialized
Yeah, that's just
issues.
because the actual issue itself in the garbage collector is easily triggered through unserialization.
Yeah, I think they
What's
specifically point
interesting
out
is
that it's. Go ahead.
What's interesting is this was reported in 2016. And this still exists as a bug.
I didn't even notice that.
Well, this is a different link from the one that we were just showing.
Yeah, good point.
I mean, the issue itself was just exploited here a few days ago. That's why we're talking about it. But the bug report dates well back. That said, if you think about what this issue is, you've got the UAF, but you're not getting... You need to be able to execute your own code, essentially. So the requirement here is that you have a class. Like part of it here is just setting that in the, or setting some code in the destructor. You need to be able to run your own destructor or provide it.
Yeah.
So with that in mind, this isn't something like on a random web app that you're going to be exploiting. You're not getting remote access. You have to be able to provide code that's being run. So you're essentially, potentially getting code execution on a machine that you already have code execution on. So it's not escalating. That's kind of what ended up happening here too, is even though an issue was presented, I don't think this qualifies as a security issue since you need a specially crafted destructor.
Yeah, I mean, it's basically a sandbox escape. It's like, this would be a cool CTF challenge, but I don't see it being abused too much in the wild.
Yeah, I mean, obviously this didn't get fixed for quite a while. It's been there. And I mean, when I first read that, I'm like, okay, this was report 2016, and, this is the PHP devs just being dense. 'Cause, I mean, there have been some cases where they've been kind of dense with some of the issues.
Yeah.
But this one, there's no privilege escalation. You already need to be able to run code. That said, this does become a security issue because disable functions. If you forget that disable functions even exist, and now that this could be used to get around it, you think people can run code? They're already doing this. Like, this isn't a huge issue. It should still be fixed. Like, I mean, it's an issue to be fixed just in general. It's a bug.
Yeah.
But when you have
allow for... I'm sorry. Go ahead.
There's the possibility that may allow for like full remote code execution. Even if it does, though, using this does, or lets you get there anyhow by using shell exec, by telling it to do that, or by telling it to run shell exec, because essentially what it does is, or at least what it looked like it did when I was taking a look at the code. Pulling it up. I don't have it saved, but essentially it looked like it was creating a little object that would end up being called. So it could, like, PHP internal representation. So it would be able to call like any existing PHP function. So if you use that like without disable functions, it doesn't seem like you're really being able to do much. It's only because of disable functions that there is a real security issue here, or that there seems to be one.
Yeah.
So it could be used for code execution in that way. Whether or not you can take this beyond that into like a proper exploit, I'm gonna take a guess here and say you can. It hasn't been done here. That's not what's been demonstrated. But just assuming, it's a UAF, there's a fair chance.
Yeah. So basically, I mean, if you're a CTF challenge creator or something, you probably
sounds like something you're going to do for us.
Yeah, why not? Let's do it. Let's make a challenge out of it. Sounds like a fun challenge.
I don't know. I mean, because it seems a little bit deep in PHP to kind of go on with to use as a CTF challenge. Maybe somebody will do that.
I can see it being used in some of the harder ones, like maybe Defcon qualifying events, stuff like that.
But then it's using a known exploit. It's
true, but it's known, but like you said, it's quite deep. I don't think you'd be able to, just pull code and instantly exploit it or anything. So
no, but yeah, I don't know. That's a topic for another discussion, though. I mean, this one though. Andy, did I get what your question was? By the way, was that?
Yeah, I mean, sorry, throat. Yeah, I mean, my question was just gonna be along the lines of, when we were discussing what code would be, you would need code on the system, like code execution availability on the system before this would be of use. To what extent?
Well, you need to be able to provide PHP code. Sorry, that's your requirement. Is you need to be able to provide PHP code.
Right, in unfiltered PHP code, right? Not just a shell on a web server, right? This would require at least a normal user, correct?
Yeah, well, I mean, as long as you can provide code, I mean, if it's being executed through eval, you can still exploit it.
Right. Okay. No,
like there are cases where you could probably expose this. Like I said, sandboxes would be another place. Mm-hmm. Like REPLs.
Okay. No, that makes sense. I just want to make sure I understood, because I know there was discussion of like RCE and it's not a privileged escalation and stuff like that back and forth. So I wanted to make sure that I understood fully. Like if we
like this wouldn't do really any privilege escalation. Like you're running it as a user. If anything, it might even be a de-escalation. If PHP is being run like through a web server or whatever it might be running is like nobody user or something, could be a de-escalation in that sense too.
Okay.
I mean, one thing, the one area I could see this actually being used in that I just thought of is like, those sites where it's like you can run PHP code.
Yeah, that's online. A sandbox or a REPL, Redux, or whatever.
Yeah, I was just thinking of that specifically. Yeah. So yeah, I guess we'll talk about some more low level stuff. So we'll talk about an empirical study of C++ vulnerabilities and crowdsourced code examples.
Mouthful.
Yeah, it's a real mouthful, and this white paper's long too. So so we'll talk a bit about it. So did you want to start this one off, C?
Yeah, I mean, I guess since we were just talking about PHP, like this was actually a huge issue for PHP developers. So what this paper kind of covers is it says crowdsourced code examples, finding code online, stealing code from Stack Overflow, specifically what they're looking at. But the idea of having vulnerable code as code examples. PHP, this was extremely common for the longest time. And it still is, but at least a lot of sites are getting better. Like SQL injection, the classic PHP example would show you, like extremely vulnerable code. And people would go and copy that code and, adjust it for their database and off they go. Actually, going back in the early 2000s, there used to be the snippet of code. It was a function getRealIP, and its intent was, if you were behind like a load balancer or something that sent a x404 header, it would give you that IP instead of the remote address that was actually making the request. Makes sense. And then that got passed around. Like if you Googled, I don't know if it's still the case, but if you Googled like how to get IP PHP, you would get that function with no mention of how or why it worked or why I was looking at the x404 header. You would just get this function and it gave you the IP and it was all great. And you saw there's extra code there, so it seemed to be doing some stuff. And a ton of places used it, even if they didn't have a load balancer or anything that would provide that header. So back then, I just put a little single quote and had my browser sending in a header with x404, single quote, and I'd just browse the internet with that. And of course, I would find plenty of errors, plenty of SQL injectable sites just by browsing. And yeah, so this thing kind of talks about those code examples. They do look at how it propagates from specifically Stack Overflow, and then looking to see if there are any GitHub projects that actually have the issue. Not for PHP though, for C++ this time.
Yeah, so I was actually going to ask, did you find anything in the paper that suggested why they wanted to look at C++ specifically? Because it just seems like it's an issue that affects all languages, so I'm just not sure why they like tunneled in on C++. I could already
No,
find
I'm
it.
not. Although I did notice that they mentioned C++ is the language of choice for embedded resource-constrained programs. And that could be why, because they felt like it was an important area to look at that isn't explored too often, because obviously I think it has been looked at or well known that it's an issue for PHP, for JavaScript, for all of that. Maybe just because it's a little bit less looked at.
Yeah, fair enough.
But no, I didn't see anything explicit about that.
Yeah, I found the method they used quite interesting. So they were saying they were basically going through Stack Overflow posts and they were parsing like code tags and then checking for the C++ tag, and then they were checking if the code was actually code, and if it wasn't, they would reject it. So it seems like it was pretty interesting how they implemented it. I don't know if do they have the source for this anywhere? I didn't see them post a link for it, but maybe I just missed it. I'm just trying to look for see if they have like a post to
I
their
know
scripts or
there
something.
was some manual aspect to it though, and it was going through a torrent of the data.
Okay.
Like that's where they got the data set from, was the Stack Overflow torrent. So I don't know if they released the source because there was some manual process. Yeah, that's how they kind of cleaned the input to find the C++ code. But then they had the manual view with this web application where people would actually like manually review the code to look for vulnerabilities or not.
Yeah, so here's a little bit of the process. I just scrolled down to it. It should go to your screen in a second, I think.
Just ignore that feature. It hasn't been working.
Oh man, it was working before.
That's
this
okay.
Like
don't talk about it.
it's the demo
unrelated.
gods.
Yeah.
But yeah, no. The other thing though, so like this paper had some fun facts in it, but one thing I'm not a fan of is they use CWEs as their metric for like pointing out specific issues and stuff. I must say I'm not a huge fan of CWEs. What's your take on it, Z?
I think it's fine for what it is. Common weakness enumeration. It's exactly that. It's a bunch of common weaknesses.
See, my problem with it and why I don't like using it as a metric like they have here is it's too vague, and they have a lot of CWEs that kind of overlap with each other. So like an example, I think their most common CWE they found is improper input validation.
So
Well,
CWEs
that doesn't really tell me anything.
Well,
you know what I mean?
So CWEs can be really vague. They can be quite specific though. There's a whole layer. The lower the number, essentially, the more vague it is. That said, even though that is fairly vague, and that was the most common finding, improper input validation.
I mean, it's just it doesn't really tell you much. You know what I mean? Like out of bounds read, cool. I know what that means. Stack overflow, buffer overflow, or stack-based buffer overflow. Yeah, I know. Like that's a specific issue. But improper input validation, that could be like a billion different things. So that's why I'm just not a fan of that. Like,
I mean,
I'm just not a fan of those specific ones.
Cause of a stack-based overflow can also be a million things. That said, what was that, CWE 20, I think?
Yeah, 20.
So you can kind of dig through one. They do provide a bunch of examples if you go on like the Mitri website.
Yeah, so I guess my criticism is less of CWE itself and just that they used like that specific one, I guess.
Yeah, I
CWE
mean,
20.
and just as I was saying, you can kind of dig through. They have relationships for all these CWEs, so you can kind of go in there. This is related to certain development concepts or research concepts, which are a lot more detailed.
Okay, fair enough.
Unchecked input for loop condition. But I think it's fair to not expect them to go in there and be like, okay, this is CWE 606.
Yeah.
The input is used in a loop. Like, no, I mean, the issue is they're not validating input. And so it might be used in SQL, it might be used XSS, might be And well, I guess it's probably not being used for XSS in your C++ code, but it does describe an actual issue.
Yeah, and I mean, to be fair to the paper as well, they actually do give some examples. Like I think one example they gave was not accounting for null terminators and length parameters, so they had like off by one issues, using malloc and not checking if the return was null, stuff like that. So they did give some examples. So I'm not. It was just something that I noticed and that kind of annoyed me a little bit. But
I don't know what else I'd
fine.
recommend them use though. CWE seems to be exactly what they're looking for. It's maybe going a bit more specific, but they don't have a ton of findings. Like that was one thing that actually did kind of surprise me. It was they found 99 vulnerable code snippets and 69 answers. That's not a lot.
No. Yeah, and I didn't really see them go into too much detail about like how they limited their scope of what they were looking for and stuff like that. So
Well, so they talked about having it manually reviewed, and then they had a professor in InfoSec or something review those, like the end results, to agree that they were all vulnerable. So there's definitely the chance of especially more subtle issues just not popping up if the reviewers weren't aware of them.
yeah, it's a good point.
I mean, Mike, are there a lot of? Sorry if I'm jumping to the side here. I mean, these look like a lot of very simple, more or less bugs. I mean, were there any ones that were like super serious, actually could cause a lot of, again, like a code execution or anything that was that serious? I don't see anything.
OS command injection?
Yeah.
They're like that's one of the CWEs they were looking for was OS command injection.
Okay, I haven't looked at it fully yet. I was just curious if there's anything from the paper that, given the number that they found, really stood out.
Yeah, like they don't talk about every issue that they found. But yeah, there are definitely some that would be potentially real issues here. Even the off by ones and stuff could potentially be significant vulnerabilities. Looks like they have format string in there also as another one.
Which I'm a bit surprised at. I thought those were basically completely dead by now.
Well, especially the sample code, you're just not really, printf my string.
Yeah.
It's sample code who's thinking about security. I did also find it a little bit interesting. They they talked to 117 projects saying like, hey, your code's vulnerable. But they only got 15 responses back.
Of course.
That said, the most common response was that the code snippet was vulnerable, but inputs were not dynamic. So
yeah,
it's not.
They showed a little bar graph thing, right?
Yeah, that's.
Yeah.
I think it's towards the end here.
Yep, right there. I think it's around there, isn't it? Yeah.
Yeah, it's
Yeah, that one on the left, I think, that you were just at.
Oh yeah.
Yeah. So most of it was it was static input or and well, some of them fixed it. 15%.
Yes, some definitely did fix it. 13 point whatever, or 13.3. I think that was. It's a bit blurry on here.
Yeah.
But yeah, some people did fix it. But the most common thing, 40%, it was not vulnerable just because the inputs were static. Now, I don't know what the actual example cases were here. But, I mean, I would say when you're releasing open source code, yeah, your input might be static, but somebody else might take your program and give it their own input. Give it their own thing. Or, adjust it for their own use. So having certain vulnerabilities, I don't think that's really an excuse. That said, I'd really have to see the case to say that, because maybe it literally is like, oh yeah, we call like add 1.1, like it's hard coded, it's not going to be changed. But I could see a lot of reasons why it might end up being changed by someone. And their kind of solution here was an in-browser static source analyzer to detect insecure code on Stack Overflow on GitHub.
Yeah, I was just about to point that out, and I think that's actually a really cool idea. I think they should actually do that. So,
I wasn't too fond of this idea, mostly because one,
okay.
static analyzers are notorious for false positives, especially if you're not able to really set it up for your specific application. It seems like the use here would be quite limited. Unless they were using like just their list of vulnerable like code snippets that they found to be vulnerable, then okay, maybe they'll have something with it.
Yeah, I don't know. I mean, you're right. Like, there's obviously issues with static analyzers, but that said, with stuff that's simpler, like example code, I feel like it's less of an issue, if that makes sense, because it's not as complex usually when you're looking at like answers and example code snippets. I don't like. There's probably ways you could get around that too. Like, I don't know if this is absolutely crazy. It probably is, but like, I don't know. Maybe if you could parse code snippets and then like somehow run fuzzers against that. I don't know. That's probably too crazy. But
Do you really want that in your browser?
I guess not. I mean,
and
I
I mean, sometimes code snippets don't run without proper input. No, that just I don't think would work. But even the static analyzer, as a researcher, okay, if I could view GitHub and then it'll automatically show me some stuff, like I could totally see a use for like an in-browser static analyzer. I just don't see it as being part of a development. I could see it being something for researchers, security researchers, not so much for the developer who would be writing the code and actually copying and pasting, as this is kind of targeted to.
Yeah. I just I mean, I don't think false positives will be enough to cripple it. Like, if it just highlights it and say, here's a potential issue, it's not guaranteed to be an issue.
Seems to completely cover the answer, is what their browser extension does.
Oh yeah, no, I don't like that, because the false positives, that's an issue. I think if you just like maybe highlight it or do a little box around it, and it has a tooltip that says this piece of code might be vulnerable. Be vigilant. You know what I mean? Check it, make sure it's okay. I don't agree with like outright just blocking the answer entirely. I think that's dumb.
Yeah, I mean, you can still view it in this case. You click the button at the base there, and you can still view the code. It's
still, I think it's too intrusive though. I think it has, or like obstructive, I guess. I think it should just
I could
be like
see
a
it
highlight.
Useful for researchers who kind of know what they're looking for and know what it means.
Yeah. So I guess we'll go on to the Signal RTP. So did you see this when this came out? Did either of you guys see this?
For the Signal one, yeah, I had but not right when it came out, but I had submitted the link here.
Yeah. Okay.
So there's kind of two issues though to talk about. One is with this Signal bug, it will process the gist of it is Signal will process the RTP packets before the call actually gets answered. Really simple. Just you haven't answered the call yet, so any exploit in RTP, that's essentially anywhere actually. If you can send an RTP packet that will result in an exploit, it can be done without somebody actually answering the call. That's the gist of it. It's an attack surface level issue. Now, this actually did get closed as simply being invalid.
Yeah.
But there's kind of somewhat related. Another issue, which I think this one kind of got a little bit more news coverage. It's a little bit more than a week ago. Being that Signal can answer, or you can basically cause somebody to answer a call. So the gist of it being, if I were to call you on Signal, I can then send a message to you that would force you to accept the call without you actually accepting it. So you do that while the phone's in someone's pocket and you start listening in on what they're talking about.
And that issue they actually did fix.
So this one was fixed. This one though is related. Basically, you send the the data line. So I believe this is still part of like the RTP messages getting sent there. You start the connection, so it's still processing everything and just sends the connect message over to the person being called. And because of a logic error, that connect message, it sees like, oh, well, the other party connected, so we're good. Just continues on to the next stage without actually looking at whether or not it should have received a connect message. I mean, it's a pretty simple to understand logic issue there.
Yeah, so it seems for the first issue, that they're kind of blaming WebRTC for that. So I've never really used.
Sorry, go ahead.
Oh, I was just gonna say I've never really used WebRTC or like I don't have much experience in that sort of area with like audio and video processing and stuff like that. But yeah, like they blame it basically saying that it doesn't support exchanging ICE candidates while not support processing RTP. So they basically have to process RTP first.
Yeah, so it limits it. You don't get the full set of candidates coming through there, and that's just basically your like network information, your public IP, your private IP port information, things like that. It's stun. It uses stun, I believe, behind the scenes.
Yeah.
So it's like that information that's not coming through if you don't have the connection. WebRTC, that group, isn't going to fix it. So like Signal can't really change that. So the core bug there, the one that was actually exploitable that leads to calling or leads to being able to eavesdrop, was fixed, is in Signal code. This other one though, I mean, it's a trade-off. They do make that trade-off. Obviously, they need to get all the information. So
Yeah.
I can understand that like the choice not to fix it. But it is definitely an attack surface issue. Especially like, so yeah, there's this logic issue that we just showing, but any exploit, WebRTC isn't a trivial protocol. So any issue in there could potentially be exploitable without the other user actually answering.
Yeah, it seems like it's one of those issues where it's like it's hard to really solve it. It's not trivial at all. It basically it require like kind of an overhaul into how the system works. So
yeah, I mean the details to fix it. I mean there probably are some solutions.
Yeah, I mean she does say in the report too that even though most RTP parsing is not technically necessary to find candidates, I discussed this with the team and they declined to make changes to it. Yeah, I mean.
Yeah, and I'm not sure if making changes would cause some like breaking issues with WebRTC, because obviously they're standard, so yeah, that could be part of why things aren't being modified.
Yeah. It just seems like there's no real winning outcome for this. I mean,
No,
at least
besides
not yet.
writing secure code.
Well, I mean, like, there's no quick fix, I guess I should say.
Yeah. Well, yeah, I mean, writing secure code isn't. That's the fix to everything. Well, everything related to security.
Fair enough. So we'll talk about the WhatsApp double free. So this is what we were. I was thinking of earlier when we were talking about the Android bug, because this is also an Android bug. It's just not in the kernel. It's in the WhatsApp. So it's a double free, which I thought was kind of weird, because I thought most heaps were actually hardened against these types of exploits, but I guess not. I guess I was proven wrong, because basically what happens in a double free, the classic way to exploit it, for those of you that haven't tried exploiting double frees, is you poison the free list. So when you free a pointer twice, you end up putting a pointer into the free list twice. So then two subsequent calls to malloc end up returning a shared pointer. So one thing grabs it that wants to use it, and then you can grab it afterwards to corrupt that same area of memory. Most heaps, though, nowadays, or at least I thought, they had some sort of protection in that. So they would, if they would check the list before freeing to make sure that that pointer wasn't already in the list.
I mean, I don't know if I necessarily would say most heaps are necessarily hardening against double free. They'll have some hardening. Like sometimes though, it is just as far as what was the last thing freed. Make sure it's not freed. Like make sure the next free isn't the same free. So as long as you can have one free separating them, you're dealing with that. Or you're bypassing.
Yeah, but this issue seems it doesn't even like they don't even have that from what I read from this. Like I know kernel heaps don't really have that because it's it adds overhead. But I thought most userland things had that. But I guess this the Android doesn't have that. So today I learned. But so it works via GIFs, right? It works through the GIF parser. The library is called Droids on Roids. I have no idea why they called it that, but
yeah, I mean, I was a bit surprised when we saw this, just because my expectation is generally if something's going to be displaying like a GIF or something on my Android device, I'm expecting it to use like the built-in Android codecs for that. So I was surprised when this wasn't using that. I guess it had to do with like a feature or particular file format that just wasn't supported yet by the Android one. So they use this third-party library, which ends up introducing the exploit for, well, everything, or for the entire application.
Yeah. So, they talk a little bit about the frame system with like the kinds of condition, like how it how it parses it depending on the frames of the file. But the main issue is basically that they reallocate it if the frames are of different size. And then if you have a frame size of 0, it simply frees instead of free and reallocating. So if you have 2 frames that have a size of 0, you just free it twice, so it's a double free.
Yeah, which to be fair, like I could understand how a dev could write this. They just because they're just passing it to realloc, which is a free BSD. Like it's just built in there, or not free. It's built into Android, like built into the kernel.
Yeah, so it's a function that like they don't really understand that it does that implicitly. That's
well, it's that, and you kind of think of how many GIFs have you seen with a 0 height, 0 width frame? Like that's just not the normal case. So I can understand why a developer might not really realize that there's kind of a special condition where it's not going to actually reallocate anything. It's only going to free when it gets 0. Because that is a special condition in the function. Just it handles 0 in that special way.
Yeah.
And it's uncommon. Like you can give it all the test GIFs that you want. Odds are none of them are 0 height and have a normal size frame before that.
Yeah. Now, I think one point that's worth mentioning that the blog post doesn't talk about is the fact that I think it's pretty important that you can control the size of the buffer because, well, actually, maybe not. Like, I'm thinking in a kernel context because in kernel you have different lists for each memory allocation size. So you have 64-byte buckets and 128-byte buckets and stuff like that. So I was going to talk about that.
Yeah, and that's a particular type of allocator, but no, in userland specifying...
Sorry, what was that? You cut out for me.
That's a specific type of allocator that uses the
slab allocation.
Like yeah.
Whereas
so userland is going to be a bit more of a generic use case. And less optimized.
So I was going to point out something thinking it was cool, but yeah, in userland it's actually not as cool. But the ability to control the buffer size is still kind of it's still kind of useful. So but yeah, that was all I wanted to point out.
But yeah, definitely not uncommon. Even network protocols and stuff kind of do something similar.
Yeah. So this blog post actually goes pretty deep into exploiting it. They actually go as far as getting PC control. So
yeah, it's a good write-up. And it's written in a fairly understandable way. Like even if you don't quite get everything, you could probably read this and get something out of it.
Yeah. So this is another resource where if you're looking to get into exploitation, it's a good read. And they're both Android. Look at that. You can get a userland execution and then you can get the kernel execution as like a learning project. It's like it's
Build the
perfect.
chain.
Yeah. So yeah, I guess you want to talk about the CNN?
Yeah, well, space spoofing
Yeah.
is essentially what this one comes down to. I mean, it was I guess just a fun paper to read. The gist of this one is basically researching into spoofing faces, where there's anti-spoofing checks in place. Specifically, it's CNN based, so neural network based anti-spoofing functionality. Paper does go into talking about. It's a pretty dense paper. Probably not what I'd recommend just reading. But the interesting here was they tried to focus on an attack that could be done in the physical world. So a lot of adversarial inputs when it comes to neural networks come down to being able to control, or they have the assumption that you control the image that's actually being provided, like the data of the image, those bytes. So you can make these little changes to it. So these bytes are this or that. Whereas this one wanted to make it so the camera would be fooled. So they talked through all the different steps of it, like the camera looking at it, or face detection, just these different aspects, and they kind of created a fake face that could authenticate as somebody else, be used in a somewhat real setup. I mean, their setup is they would display using a monitor, so it's not like you would hold a picture up. Unfortunately, it had to be a monitor, but it had some interesting aspects to it where adding in like facial alignment in their spoofed images didn't matter. You can't really make it out too well on this, unfortunately.
It's funny to me though that it works with a monitor because, like, have any of you like put a phone up to a monitor and seen like how the light messes with it? You get all those like grid lines going everywhere depending on the angle
So
and stuff
that
like
depends
that.
on the type of panel, though.
Okay. Because I was thinking, like, I feel like that would really mess with a neural network, but
It definitely can. I thought it was more interesting how once it detects the area of the face that it's going to compare against, it doesn't care what the background looks like, and that's why like these faces here, like even though they're a little bit small here, you kind of tell they look a bit weird. Like proportions aren't quite right with those faces there, and that's obviously with the faces being misaligned there. Because it only looks for that one detected area, it really didn't matter. But it didn't matter very much, I should say. Nonetheless, they did also test it with kind of corrected, properly adjusted faces. But yeah, I mean, the paper is really dense, getting into a lot of the more complicated math on how they're actually generating the adversarial examples, which frankly goes beyond me.
yep, definitely goes beyond me.
So not going to talk too much about that. I just thought it was kind of an interesting aspect to the attack to look at, actually trying to replay from something physical. Like, in theory, you could do this against an actual face scanner. It doesn't assume that you can provide the actual input or control the actual data being read, but you can just show it an image that gets through the spoofing by, well, in these cases, all adversarial examples. On that note, though, this kind of comes down to, is AI the right choice for this type of application? The more, because we talk about AI issues quite often. And it always comes down to, these adversarial issues, and like little changes, everything breaks. And while I like the idea of AI, I get the feeling though that there's no real way to prevent this. Yeah, you can do training with adversarial data, as some things recommend and should be done. But it seems like you just come with another way to generate adversarial stuff, because it's not explicable AI. With explainable AI, at least we can kind of see and maybe create something that's a bit more deterministic, I guess it'd be. What I'm getting at is that should these security resources be so AI based or be a bit more deterministic? And I'm kind of leaning towards we should probably work these to be a little bit more deterministic.
Yeah, I mean, AI is just too much in its infancy. You know what I mean? Like, I don't think enough is known about it yet to be able to deploy it in a security context. And it, like you said, like it's too easy to spoof right now. There's like
Well,
these
it's
kinds
not
of
even
attacks are.
spoofing. It's just, the whole adversarial attack in general.
But I mean, like those types of attacks are mitigated, like the more samples you have, right? But
Yeah,
I
but
mean,
I mean, just because I guess my feeling is we don't know how the AI is actually coming to its decisions. It could be coming to its decision because there's always a gray pixel in this one position every time. By chance, that always works.
yeah, I mean, I probably don't have enough experience in the field of AI to give a valid opinion. So I just think it's not ready yet. There's too much unknown about it.
Yeah, well, that's kind of what I'm getting at. Like, it's not something that I think explainable AI could help it be a little bit more ready. Yeah, I mean, I don't know how often it is actually used for facial detection. I have a feeling though it's getting more adopted, and I don't know. I wish it was a bit more deterministic. That would kind of be
I
my
mean,
preference.
on that point, isn't there like cameras in China and stuff like that that have automatic face recognition in the cameras? I feel like I heard something about
Oh
that.
yeah, that's definitely done. I don't know if they're using neural networks for that though, or if they've got a more algorithmic approach.
Oh, okay, fair enough. Yeah,
Which is kind of like I'm not against. Well, the surveillance is a whole different topic, but
yeah. I just wanted to point that as like a potential example, but
yeah, I don't know if they're always using neural networks though, because it seems like these neural networks work really well, but they also have these really unpredictable issues.
yeah, yeah, that's fair. So, do you guys want to move on to defense from offense? Go to some mitigation talk.
Well, at least this next couple are somewhat on the mitigation. Yeah.
Yeah. So, if you guys didn't see, Google came out with two tools for instrumentation: kernel thread sanitizer and kernel concurrency sanitizer. So KTSAN and KCSAN. I have it in my notes as KC-SCAN. I don't know why. Fix that real quick.
Sanitizer.
Yeah, Sanitizer. Um, so basically, it tries to look for data races.
Yeah, and
So
just to kind of mention here, I saw this come up in a few places as are being presented as though it's looking for race conditions, and this is definitely data races and not race conditions.
which
Whether or not
confused
data
us too.
whether or not data races are race conditions is a very debatable topic. But that's it. This is specifically just kind of give people an overview here. Data races are generally that situation where you have two memory operations going on. One's a write, at least one's a write, on the same location memory at the same time. The issue there being like that one thread can end up mutating the value that the other reads. So imagine you have like 2 bytes, and one thread reads by the first byte, and while it's reading the second byte, or before it reads the second byte, the value gets updated by another thread, and then it reads the second byte, and so it gets like half of both values, or like 1 byte from one value, 1 byte from another value. It just ends up corrupting the memory. That's a data race. Whereas race conditions, you can have an application with no data races and you can still have race conditions where it's more about time of check or time of read versus the time of use or actually updating. Like the change happening in there, it's related, but not quite the same.
Yeah. So, I mean, we talked a little bit about this before the podcast, and I'm not gonna lie. Initially, I thought it was for race conditions as well. I didn't I didn't read enough into it to see it
Yeah, well,
was
that
for
was
that.
how the first link we had actually presented as Google released tool for race conditions.
Yeah. So, I mean, it has an impressive result set. I remember you bringing this up. Do you have the link for the result set? Because I remember
Um,
we
I
what was
don't
that?
have it on hand actually, but it was 300 issues were found in 2 days. And the key thing with this is it essentially works by instrumenting all of the data or all of the data access that it cares about, and essentially looks at them or freezes when it sees them, whatever, instruments it, and looks for anything else that could have accessed it at the same time. And it found a ton of issues really quickly.
Yeah, so I think I found the link here. So this is a list of some of the issues that were found. So they have like a small listing. There's other ones, but they haven't disclosed them because they haven't
Well,
been
so
fixed yet.
these were the ones found with KTSAN, not KCSAN.
Yeah, sorry, they
KTSAN
haven't.
has been out for a little bit longer.
Yeah, so sorry, they haven't listed. I don't think they've listed the ones the KCSAN has found
No,
yet.
and that's where that 300 number comes from, is stuff from KCSAN.
Yeah, okay. So
And just to be clear, it's two different methods of looking for these data races. The two tools are two different methods. Go ahead.
yeah, so I was just gonna try to go to where they actually mentioned the two different methods because I think kernel thread tries to look for it before the data race happens, and
Well, it's a
is that
happens
what it is?
before. Well, no, happens before relationship is more of a concurrency. It's just a formal term in terms of being you can two atomic actions will have a happens before relationship. I think that's kind of what you're getting
Yeah.
from,
So
because it's a happen.
that's
It
what I
looks
meant.
at the
Yeah.
happens. It looks for the happens before relationship, but all that means is that one will occur and finish before the other one can execute. So two atomic actions will do that. If they're not atomic and have no lock or anything around them, they won't have a happens before relationship.
Okay.
But yeah,
That explains a little bit.
that's just a little bit more formal. The term itself is just out of like formal concurrency logic or whatever you want to call it.
Yeah. So I mean, what I take away from this is Google's really going ham on kernel instrumentation. Um, like instrumentation's getting good fast, and I wonder if within the next couple of years we will see something for more generic race conditions that aren't like data race induced.
Yeah, I don't know. I mean, it's definitely possible. Well, I guess it's debatably possible. The thing is, like, especially with any of these dynamic things, you have to be able to trigger the vulnerable condition. And so it can be quite difficult to even accidentally trigger some race conditions.
Yeah, the window, like sometimes you have to specifically try to hit the window, like doing like tricks with setting up the scheduler and stuff with your code to try to hit it
Yeah, well, I mean,
or increase
that's.
your probability of hitting
Well,
it.
yeah,
Yeah.
pretty much any of that. Like, there are definitely some very subtle bugs in race conditions that make it difficult to
Yeah.
just fix with instrumentation. That said, we did talk about the one fuzzer. This was, I want to say, somewhere around like episode 8 or 9, where we talked about the that one fuzzer that used timing.
I remember vaguely about that. I can't remember.
Yeah, that. So there is some tooling that has come out recently about that. That was just a research paper yet that looked for it. But I remember
Yeah.
thinking that could be used, or that technique could potentially be used towards some race condition checks. But yeah, I mean, I think a big part of it is going to have to come down to static analysis to detect them.
Sorry, you
Which
cut out a
is,
little bit. What did you say there? Dynamic analysis? Is it?
well, static analysis will have to be used to detect
Oh,
them.
static. Okay, the opposite. Okay.
Yeah.
Okay, yeah, you cut it. It said attic, and then that's all I heard. Yeah, so I mean, that erases, not race conditions. That's an important point to notice.
Yeah, I mean, otherwise
tripped
it's
me
not
up.
really something that we'd really even talk about on here. Like, it's a tool that's been released, but it's not strictly speaking security oriented. But
Yeah.
it was definitely presented in a number of places as a security oriented tool. And to be fair, some data races are also race conditions. They are, or they can also introduce security vulnerabilities.
Yeah.
Uh,
So, well, I guess we'll start talking about eradicating attacks on the internal network with internal network policy.
yeah, I'll just say up front, this is... I think it's kind of a stupid solution here. So
Really? Okay.
the gist of this is, one, you kind of have the issue of a DNS rebinding and CSRF based attacks being able to reach your internal device. So imagine you have your router accessible on some internal IP. You can either use a CSRF attack to make a request to it, or using DNS rebinding to get around same origin policy. It's a real issue, like not letting external websites access your internal IoT devices or your router or something. Absolutely a legitimate concern. That said, their solution here is to start having the browsers keep track of what IP, or if something's external or internal. So essentially, they're recommending that it should track enough that it can detect DNS rebinding. And if anybody's not familiar with DNS rebinding, the gist of the attack is you take your attacker.com website, that's your maliciously controlled website, and you set it up with a really short time to live for the DNS request. So DNS just being, how you go from attacker.com to the actual IP you connect to. So the first time the user makes a request to something at attacker.com, they get your malicious website. And they'll have a script or something like that that gets loaded that ends up causing another DNS request because the old one has already expired. And that second time, it gives it an internal IP address. So it thinks it's still communicating with attacker.com, but you're actually communicating with, 127.0.0.1 or some internal IP. It essentially just changes the address that it resolves to. And using that, you can, from the outside, interact with internal applications. So what this is kind of suggesting is that we have this thing called an internal network policy. So it's a new policy like same origin, except with internal network policy. It'll still make the same thing like a pre-flight auth request if it sees a request that's shown. It's just now it's on the browser to take note of this and send a pre-auth or pre-flight authentication request before actually allowing the main request. The reason why I'm not a big fan of this is because it feels like it's really a complicated solution for something that, as far as I'm aware, has no legitimate uses. So what I mean by that is there are 3 attacks that they cover. 2 of them are DNS based on DNS rebinding. 1 is CSRF. So the CSRF one, websites should protect against CSRF on their own. Any IoT application, there should be either needing a token, needing some sort of validation that this was an authentic request. Websites can protect against CSRF, including IoT applications. This is something that should be on the application side to prevent. So that attack, we just don't need it. Or I think it's wrong to put it on the browser to need to fix that. And the DNS rebinding ones, I think the browser preventing DNS rebinding is a legitimate request. I think there has been some look into what browsers can do to harden against it. But even so, any web app can still protect against that by looking at their host header. Either they shouldn't have a host header if they're like a little IoT device, or if they have one, it should be, something somewhat expected. That little thing would then effectively remove using an attacker-controlled website to access it if the host header was checked. And I mean, the host header can be checked by the load balancer or anything, or since we're talking about internal, like the IoT device, if it's using like an IP or something, you just shouldn't have a host header. Like, there are some really easy solutions here. I don't think we need to introduce a means for DNS rebinding to actually become like a practical web technology. That's kind of my concern here, is there's no real use for DNS rebinding. There's no reason why any pre-flight auth request should be validated with this INP, with the internal network policy.
Yeah, I mean, like you said, it was convoluted. Like, I read through it and I was like, I still didn't really understand how like exactly what it was doing. Like, it was talking about sending like pre-flight requests, and I don't do a lot of web stuff,
or
but...
like CORS does pre-flight. It's the same thing. When the browser sees that a request is being made that it violates like same origin policy, it will make a request, or it'll make a request to that same endpoint, just as a head request, so not a get or a post or anything. No, nothing that actually matters. It'll just make the head request, and it'll look for a response. It'll look for a header telling it okay if it's, it'll list out like certain constraints on what can send or what can send requests to that endpoint. So that's what they're expecting, is basically adopting that same idea onto internal websites. IoT apps now need to support that.
Yeah, okay. There was one other thing I wanted to ask about. I was reading their conclusion, and they have this one sentence. We realized that no matter which attacks are used, the browser would eventually be instructed by an external entity to access an internal network resource. So, like, what are they trying to say here? I'm a bit confused on what they mean by this. Like,
well, even if, assuming this is including their protection there, the pre-flight auth is still a request to the internal service. It's still making a request. It's just not making the potentially damaging request. Or, if it's misset up or something and doesn't care, like, oh, it just looks at the endpoint or something. Like, if it just... Sorry, I got distracted.
yeah, it's all good.
Essentially, I believe what they're saying there is a request will be generated regardless of the protection. It's just not necessarily going to be that same request, but a request still will go in there, and that can still be damaging.
Okay.
It would help, like, if you understand kind of what a pre-flight auth request is. Because it's essentially saying, yeah, that's still sent. You can't get around that request.
Yeah, I mean, I figured, some of the things I didn't understand about the paper were more on my part than the paper's part. Not like having a knowledge gap in that area. So I just wanted to ask you about that, because I figured you probably knew a lot more about that than me.
Yeah,
so,
which is fair. I mean, I kind of summed this one up. It's a complicated solution that I don't think is necessary, because applications can fix this on their own. And the only thing that really applications can't, well, they can defend against, but the DNS rebinding aspect, and DNS rebinding should just be blocked outright. Like, there's, as far as I'm aware, there's no legitimate use for DNS rebinding.
Okay. That sums it up pretty well. So I guess we'll move on to our last topic of the day here, which is analyzing control flow integrity with LLVM-CFI. So,
interesting paper. Took me a few reads.
Yeah. So one thing I will say, we don't have it on screen, but so this is from Arvix, and there's a summary page that they have, and it was like the most difficult shit to read ever. I swear to God, they had they had dashes everywhere, and they didn't have enough spaces. So it was like, I don't know if you read the summary at all. I was trying to read it, but yeah, it wasn't fun.
I had read it. It seems like it was basically a copy and paste or somehow auto generated, and that's why like missed spaces in some locations and things like that. They used LLVM, like just missing the spaces or places where there was a line break, probably in the original paper.
Yeah, it actually looks a little bit better than it did when I looked at it, but
it's still a little bit of a pain to read.
Yeah, but yeah, that's just something I wanted to point out. But yeah, the paper. So it talks about CFI. So for those of you that don't know, CFI, it's control flow integrity. It's basically it tries to prevent you from doing stuff like ROP. So you can't like just jump into the middle of functions and stuff like that to, construct your own functions. It just basically tries to prevent code reuse by making sure that you're jumping to valid functions and stuff like that. What I found a bit confusing was they said it was a static code analyzer, or a static source code analysis framework, but it's actually they built some like on top of LLVM itself. So it was hard to I wanted to look into
so the LLVM stuff is how like they're using LLVM and its IR to as its source to analyze. Like it analyzes the IR. That's where LLVM comes in.
Yeah, I mean, I just wanted to look into the source a bit to see how it worked, and then how big LLVM is, it was difficult, man. I mean, I had to look through the commits, and even then, I couldn't find everything. So,
well,
I wanted to talk a bit more about it.
Isn't this kind of their own standalone thing? You don't need to look at LLVMs.
What's that?
You shouldn't need to look at LLVM's source. This is its own tool. It's just built on it's built on the compiler framework.
I mean, if you go to their GitHub, it's basically a modified LLVM. So
yeah,
the commits and everything
are gonna. I see what you're saying.
Yeah, it's hard to parse what's LLVM's work and what's their work. You know what I mean? Like the commits are kind of mixed in, and yeah.
That's how I was able to look at it. It was just the commit author.
Yeah, I mean I saw some of the commits that were done by the researchers mentioned in this paper, and I did look at them, but it was more of a pain to try to figure out which code was which. So it looks like it's been in development for quite some time, because I saw some commits from, I think, that Matthias Neumer guy. I think I saw some commits from him on it from 2017. So they've been working on this for a few years. One thing is, though, I don't think they directly link to their GitHub source in the paper. I think I had to go... Oh, no, actually they do. It's just really small. So, yeah, never mind that point. That was another paper I was thinking of. So, yeah, they did actually link to it. So, you can check that out if you're interested in the implementation specifics. But
I will say, in terms of the paper itself, they mention this as being, this is just for the static... like a framework to analyze different CFI implementations, which I guess we haven't really said. That's kind of the gist of this, is they're using this to be able to look at the effectiveness of different CFI setups, basically, different restrictions and stuff. Realistically, and that's kind of the whole paper talks about the policies, background, describes some of the different restrictions. And then you go to the conclusion, you realize, but the whole thing that they really seem to care about is the fact that this can be used for automated co-op attacks. If you're not familiar, co-op being counterfeit object-oriented programming, kind of like a take on a ROP, but uses C++ as the virtual methods, chaining, invoking chains of virtual functions. Through existing call sites, so that's how it gets around the CFI. It just automated to find those gadgets. So that seems to be the big thing that they were happy about with this. The whole paper, though, is written as though it's defensive, and then the conclusion is all they're offensive, which I thought was just kind of a fun little thing, because it's clearly dual use. Clearly they had one intent, and somebody was kind of forcing them into presenting as a bit more defensive.
Yeah, probably some pressure from the universities or whatever. But they do mention the dual use case. Like they said, it's intended to be used to analyze existing CFI defenses or by red teams to bypass existing CFI defenses. And if people use it, I imagine it'll be pretty much entirely for the latter. It'll be used for bypassing. I don't think it'll really be used for analyzing.
Pretty much. I mean, that's definitely where this isn't a completely automated co-op attack generator, but it's the gadget generation. It definitely helps. It's better than those that just try to find like ROP gadgets, because you don't know which ROP gadgets you can actually call without doing a lot more legwork. Whereas this is kind of looking at what restrictions are in place on what can be called, and being able to find the gadgets you can use in light of the CFI restrictions in place.
Yeah. Yeah, so I mean, can't go into too much of a discussion about what this does, because like I think we just pretty much summed it up.
Yeah, I mean, that is
going to be used as a red team tool.
That is the summary of it. If you want, I mean, you can always go read these papers. We include all the links. I mean, you can read the paper and see exactly how they work. I'll probably also include a link to the co-op attacks, just because I feel like co-op attacks really haven't gotten a ton of attention from anyone.
Yeah, I mean,
they're a few years old, like 4 years old. This is, I think, kind of the first paper on it. I mean, 2015. Oh, go ahead.
I was just gonna say, one thing with CFI is it's pretty much like, from what I understand, it's mostly Windows stuff that does CFI. It's not very common in like Linux or anything like that.
Doesn't iOS do some, or is that just CFG?
I'm not sure. Actually, that's a good point. I'm not sure if they do CFI or not. But like, my main point is, like, I know it's not uncommon to have never needed to bypass CFI at all, even just because it's just not that common outside of maybe iOS and Windows. You know what I mean?
It doesn't look like it's used on iOS, at least not yet.
Apple might have their own version that they call something else, because they love doing that.
Yeah, I just did a really quick Google on it. Didn't come up with much. That said, I mean, it's going to get adopted, I think, coming into the future, at least on more hardened applications. I can't see it not being used. It is extremely effective. I mean, unless maybe you disagree with me, but I think CFI is quite effective at preventing a lot of code reuse attacks.
I mean, I don't directly disagree with you, just because I haven't really needed to bypass CFI, but I have heard, I have seen quite a few CFI bypasses. So,
well, I mean, but you've also seen, ROP bypasses the non-executable.
That's true.
There's that. Yeah, there are bypasses. Of course, there are bypasses, and even perfect CFI, there would still be bypasses. Fun fact, that's actually, I believe it's been mathematically proven that even with perfect CFI, there would still be bypasses. In theory, it's not a perfect solution or anything. But
do you remember why, or if not?
No, I just remember that being mentioned in passing. I have not looked at it. I might be completely wrong, so don't quote me on that or expect me to be right.
Okay.
But I mean, my whole thing there is just, CFI is quite effective at preventing a particular class of attack. The issue, co-op attacks, work mostly because CFI just isn't well trained to understand virtual functions and how that works, so it allows all these very dynamic call sites. Just by the nature of how virtual functions work in C++. That's the thing. The co-op attacks that this thing looks for gadgets for is a C++ specific thing. It's not so useful in C, which doesn't have virtual functions.
Yeah. So I think that pretty much sums up all of our topics. Did you guys have anything else you wanted to add before we end off the show?
No, I believe that's all.
Yeah,
Nope,
that's
I
it.
think you guys covered it all pretty well.
Yeah. So, if you guys are interested, when the VOD goes up, all the links and the timestamps and all that kind of stuff will be in the description. So you can check out any of the stuff that we talked about. And one thing I will say, get it out of the way early, is when the clocks do fall back, what is it, November 13th or something like that? We will actually be respecting that. So we'll still be on at 3 p.m. Eastern when that daylight savings times hit. And the reason I say that is because actually Z is actually in a time zone that doesn't respect savings time. They don't like it over there. So
We avoid it, but yeah, we'll be 3 p.m. Eastern. We'll be back next week again. We are back, so we should be back every week.
Yep, Zai's back from leaving us. So so we'll be back again next week, and we'll see you then.
All right, see you guys.